all very welcome. Thank you for joining our booth. This is for the BEME in Electrical and Electronic Engineering. So my name is Maeve Duffy. I'm the Programme Director for this programme, and I teach. I'm a lecturer in the discipline, and my area is in electrical power, machines and control. So I'm just going to spend about 20 minutes going through some slides, and hopefully we'll have some time at the end then for questions. So if you have any questions, you can put them in the chat and we'll go through them then at the end. Okay, so electrical and electronic engineering is the area of engineering and electronics that connects technology to the world. So it's really about building the electronic hardware and interfacing it with the software and the IT, so it can interface with the real world where we live. So things like your mobile phones, your electric car, your electricity supply, all of that is covered in electrical electronic engineering. So like I said, it covers a broad spectrum of electrical and electronic technologies. So right down at the level of individual silicon chips, and we teach you how to learn about to design circuits on silicon. So companies like Intel or Analog Devices, then putting circuits together. So once the chips are packaged, to build them with other circuits and with other circuits, and put them together in a circuit board to make into something useful. That might be the circuit board for a mobile phone, for example, or another handheld device. There's a lot of communications technologies, so putting them into larger telecommunication systems, so the infrastructure for that. A big area, of course, is power electronics, so processing of electrical power, whether that be, converting the energy from the mains so that it can recharge your battery for your mobile phone, or of course, delivering power efficiently from one side of the country to the other, using the the design of the electrical distribution and transmission system. So that's pure electrical engineering on one end, and electronic engineering and microelectronics at the other. So you can see that we cover a broad range of different technologies all throughout the course. And as a result, when you finish your program, you're given the chance to work, you're trained to work in a wide range of different career paths. Okay, so just looking at, say, some recent job announcements, you might have heard Intel announcing that they're looking at Galway for building a new fabrication facility. Borden and Mona is looking for engineers to develop greener energy systems. Bosch has opened a new development centre in UL to develop technologies for electric cars. And then we have Valeo just outside the road in Tuam, who are also highly involved in electronics for automotives, but more for the safety features in automotives. So that's just a flavour of some of the recent job opportunities. What we see is that, we get a lot of companies contacting us to ask, are there any graduates available with skills in electrical electronic engineering, because there's a lot of job opportunities in Ireland and abroad. So there's more jobs in Ireland at the moment than can be filled by all the graduates from all the universities in Ireland. So there is a shortage of graduates with skills in electrical electronic engineering, and that's partly driven by the big emphasis now on energy and efficient electrical supplies, but also on the development of new intelligent and highly networked devices like your mobile phones, but also, other everyday objects that are becoming connected through the internet. They need electrical electronic engineers to design the technologies that will enable them to become smarter and more efficient, and so on. The different industry sectors that we see our graduates working in would include automotive, of course, aviation, communications, so O2, Vodafone, energy, ESB, EirGrid, finance, of course. So a lot of consultancy, financial consultancies, to develop IT systems for them, but even they like the way that engineers think and process, analyze data. So there's lots of opportunities in that area. Healthcare, of course, developing biomedical or medical devices, media, software, sports and exercise equipment, which is also becoming more and more intelligent and connected so that you can monitor your activity. So the degree that we have, just looking at some characteristics, it's a BE-ME in degree in electrical electronic engineering. So it's a combined bachelor's master's degree. So it's 5 years integrated program. That's how it's been designed. But because the new 5-year structure has only recently been introduced, there is still an option to exit with a bachelor's degree after 4 years. Like all of our engineering programs, there's a 5-month placement in industry, which is paid. And that's at either the end of 3rd or 4th year, depending on whether you decide to continue for the 5 years, you do your placement in 4th year, or if you decide that you want to finish with a bachelor's after 4 years, then you do your placement in 3rd year. So normally the year before you graduate. Our degree is fully accredited by Engineers Ireland, which means that it's recognised throughout the world. So Engineers Ireland is the engineering body that represents the engineering profession in Ireland, and it provides a set of criteria that our programs have to meet to ensure that it's up to the standard that is required for chartered engineering status. And then that means that the degree is recognised worldwide. In the program, we use a variety of teaching and learning methods because it's engineering, it's not all lecture-based. There's a lot of problem-based learning, assignments, and of course, a lot of laboratories and project work as well. So what types of areas do you study when you do electrical electronic engineering? So this is a graph of showing you the breakdown in the different areas of study in electrical electronic engineering. So these are quite general areas for now. I'll show you the modules on the next slide. But because as an engineer, like I said, the program is accredited by Engineers Ireland. So they specify a range of areas where our graduates need to have some skills. So it's not all technical electrical electronic engineering, but of course that's a big part of it. Design and development is here. I'm just noticing the colors are a little bit off between my graph and the legend, but we'll go through it. I'll explain what they are anyhow. So there is a lot of design and development because that's basically what your job involves a lot of the time. And engineering practice would be kind of the best ways of doing things. So what's a good practice? So we teach you good engineering practice related to electrical electronic engineering. Just maybe I should start at the bottom. So science and maths is kind of the foundations. And you can see, you get a lot of science and maths at the beginning, but then it becomes less as the years go on. Then the next is actually discipline specific. So the color is wrong there. I'm sorry about that. But anyhow, this is the discipline specific chunk of material that you do. And you can see that's quite dominant all throughout all the 5 years of the program. So that's where you're learning about the particular skills that you need in electrical electronic engineering. There's also ICT, information communications technology, so software, programming, because I mean, obviously all engineers need to know a little bit about ICT anymore as things become more connected, and the use of software for modeling and simulating systems before you build them, and then to troubleshoot as they in case if problems arise. So then design and development will be this chunk. So there's a little bit in first year, but you can see you get more and more design skills so that when you leave, you're fully qualified to take on your own designs. And then I've said, this is the engineering practice, which is, how to do things properly, so that they're safe and that they're sustainable and so on. That's the engineering practice bit. And then social and business will be an appreciation of, the impact of what you design and understanding of that, to make sure that if you're designing a new product, that it's safe, that it's using materials that aren't going to damage the environment, that they're sustainable, that your system is efficient, and so on. And then in terms of the subjects that you the subject areas, so there's the subject areas are kind of in streams. So yes, now it's not representative of the amount of each of these subjects, but just to show you the different boxes that you will have modules in. Obviously, maths is again a foundation, and science. Maths and science will be the foundations of engineering, because all of our engineering principles are based on scientific principles, and using maths then to describe the physical world. So it's more like applied maths, if any of you are doing applied maths. There's also, some mechanical engineering, and there's some business aspects. So these are kind of outside of core electrical electronic engineering. So mechanical, because a lot of the electrical systems are quite large and big. So you need to have an appreciation for the mechanics that are going to support them. Business side of things is to make sure that you have an understanding of the cost of what you're developing, and that you can make proposals for new projects if you're involved in, say, new startups, or even companies that are involved in innovation. On the technical side, then, there's analog electronics and electromagnetics. It's kind of a topic area, so it'll be like electronic circuits at the small scale, and electromagnetics is looking at making sure there's not too much interference produced by the devices you develop. Then there's electrical power, machines, control systems, and power systems. That's very much electrical engineering. So for companies like Airgrid or ESB, Bord na Móna, those are the topics you'd be covering for related to those jobs. There's a big thing, of course, on communications and signal processing, where, like I said, mobile phones are an obvious example of where communications technology is needed, but so too the internet and your laptops, and all I'm sure you might have heard of the Internet of Things, where they're trying to connect everything in your house to the internet. So for example, your lights, your fridge, your cooker, your heating system, so that you can communicate from where, you might be away at work, coming home, you can go onto your phone and turn on the cooker, or check your fridge if something, to see if you need something. So this will be all Internet of Things, which needs communications to allow them to happen. And there's a lot all throughout. There's laboratory and project work. So you're learning the theory in class, and then you're putting it to practice in the laboratories and projects. Okay. So just some highlights. I'll go through these quickly enough because I think we're running into time. So we have so like I said, there's a lot of project work, and that starts right in first year, where you do group projects. So you get a feel for multidisciplinary engineering projects with civil, mechanical engineering students. In second year, you do a group project on designing your own musical instrument, and that will be using household objects to design a musical instrument with electronic circuitry, of course. In third or fourth year, when you go on industrial placement in the Professional Experience Programme, PEP, you get industrial project experience. So depending on the company that you go work for, that's the level of experience that you get. And then in the final year, whether that's fourth or fifth, you do an individual project, and you know, you're allowed to focus on technology of interest. So we've research interests in power and energy, biomedical devices, automotive electronics, consumer electronics. So there's a good range of interests. And if you have an idea yourself that you might bring back from placement, there's an opportunity to focus on that if it's feasible. And just, you might have heard of the Galway Energy Efficient Car project, the GEEC. So our students in electrical electronic engineering design the circuits that that provide energy from the battery to the motor of that car so that it's as efficient as possible. So there's a lot of building and testing of circuits and then putting them into systems like the GEEC and testing them in real life. So just, this is a flavor of some of the companies where students go to work in placement on internship. And of course, then they also may end up as graduate engineers in these companies as well. So you can see EirGrid, ESB, that will be energy related. Intel, I think Analog Devices should be there as well. That will be more microelectronics. Aerogen, BMR, Crosspond, that's biomedical electronics, and there's lots more of those. HP, ARM, IBM, so they're more the computer communications companies. Jaguar Land Rover, Valeo, again, they're automotive electronics. So there's a huge range of opportunities. And indeed, there's some names there you mightn't recognize, but they might be startups from our graduates or indeed from the university through research. Another recent highlight is that we have an exchange program with Purdue University in the States, where Purdue is located. The university is in Indiana, near Minneapolis and near the Great Lakes. So it's one of the biggest engineering schools in the US. And we recently realized that Neil Armstrong was a graduate from the science program in Purdue. But anyways, there's an opportunity in third year to spend your full third year in Purdue, if that's of interest to you. We have 2 places per year for that. And the other highlight that we're quite proud of is our engineering building. We've only recently stopped calling it our new engineering building, but it's a building, it's called the Alice Perry Engineering Building, after the first female graduate of engineering from the UK and Ireland, Alice Perry. So this allowed us, we were in different buildings located across the campus. Ourselves, we were down in Nuns Island, but this building has allowed us all to come together in one building under the one roof. Our labs are up on the 3rd floor because electrical electronic equipment tends to be quite small. The circuits we're building are usually quite small, while civil mechanical are down on the ground floor because they've got bigger bits of equipment to use. So our labs are up here. We've got teaching classes down the back, and then our staff offices are the other side. And then this area to the front is our postgraduate research area for all engineering students. So I think that's everything I had to say. So I'll stop there because I want to give you a chance to ask questions. So the slides should be available afterwards. You can get more information. It's quite a long web link there. But if you search under the school, the College of Science and Engineering and the School of Engineering, we're electrical electronic engineering. And you can email me if you have any questions. Okay, so I'll just stop that and I stop sharing and I'll move to the chat just to see if anyone has put in any questions or if anyone has any questions now. Okay, so one question is, in terms of job demand worldwide, how do you categorize the jobs? High, medium, or low? I'm not sure what you mean, but in terms of job opportunities, yeah, job demand worldwide, okay. So there would be a lot of demand for graduates in electrical electronic engineering, not only in Ireland. I mean, we've had, because of contacts, Irish contacts we've had over in Austria, I've recently had somebody emailing to say, do we have any graduates? We can't get any suitable graduates in Austria. I don't remember the name of the company now, but I know Huawei are also looking for graduates based also in Austria. I think this was on semiconductor or maybe ST microelectronics. But equally in Ireland, you know, there's on semiconductor, there's analog devices, there's Intel, they're the big names. But then electrical electronic engineers are needed in other sectors like the energy sector, obviously, but biomedical engineering, so Boston Scientific, Medtronic, they take a lot of our graduates as well. A lot of the time, they're just looking for good engineering graduates with skills, and then, you know, with good engineering analytical skills, and then they train them in the particular area that they need them to work for their industry. So I hope that answers your question. Ibram. Were there any other questions? I don't think so. Yeah, I mean, we're one thing to say is, you know, we're delighted to be back on campus. This year it makes a big difference in that we're able to bring our students into the labs and give them some hardware experience using the instrumentation and whatnot, which again is very important. And even during the lockdown, you know, students got placements. They were on internships in companies. A lot of them were working from home, but they were provided with the software tools or with the communications tools that they needed to give them as good an experience as other engineers in the field. So I don't know if there's any other questions. You can always send me an email afterwards, or there might be a chance to put questions in the main system today. Again, Ibrahim, this program combines electric and electronic. Isn't it better to do either one of them in terms of, well, no, well, when it comes to your jobs, so I guess the idea of the degree is to provide you with a broad range of skills. The reason that we're able to train you in electrical and electronic is that it's the exact same laws that are applying, you know, at small scale electronic circuit level or at large scale electrical level. It's still Ohm's laws and things like that. They're the fundamental laws that are applying. Obviously, it depends on if you're designing circuits on silicon, you're dealing with different materials than if you're designing circuits with copper wires and bulk resistors and so on. No, I guess this is a fundamental degree. So the idea of electrical and electronic is that you're getting the fundamentals in electrical, electronic technology. Some people find it hard to know the difference. So that then you're trained for a different range of career paths, and it's up to you afterwards to decide where to go. There is a chance to specialize in the 5th year. So in the 5th year, you have a choice of modules. And at that stage, you'll have been on placement. So you'll be able to choose your modules to steer you in a particular area. As far as I know, the presentations are going to be saved and made available afterwards. So it might be, you know, later on today before they're available. But if you've registered to join, you'll be sent details of how to get the link to the presentation. Thank you, Daniel. Jack, would a student doing undenominated engineering and choose to specialize in electrical electronic engineering graduate with the same qualifications? Yes, absolutely. They would. It's the exact same. So in 1st year, even if you choose, even if you choose electrical and electronic engineering, you sit in the exact same classes across the board with undenominated engineering. So all 1st year engineering students take exactly the same modules for the full year. So there's no difference between what a non-denominated student takes and a student who has chosen to take electrical and electronic engineering from the start, or indeed a civil engineer. They take all the exact same modules. Okay. You're welcome. So I think I have 1 more minute left, and then we have to give up our slot for the next talks at 2 o'clock. If there's any other quick questions. No. I know there's another talk on our sister program. We have a sister program in electronic and computer engineering, where instead of us focusing on the electrical side, those students do the same electronic and communications modules, but they do more software. So IT and computer science modules, while our guys are doing electrical power, control systems and machines. What's the difference between electronic and electronic? You mean electrical and maybe if you want to put that question in again, I can try and give a quick answer. Martin. So between electrical and electronic would be circuits on silicon usually, and electrical is higher power circuits, where it's electricity you're dealing with. Electronic, it's more smart devices, and so smart devices, electronic, so designing computer chips or digital logic circuits or sensor circuits, that would be electronics. And then electrical would be more dealing with electricity, so high power, high levels of electrical power. But it's the same fundamental laws that are applying, I guess, in both. They're very, very closely related. So that's why we have one program together. Okay, so I better leave it there. But if anyone has any other questions, you can put them in the main chat of the main open day forum, and I or somebody else will come back to you on those. Okay, thank you very much for joining, and enjoy the day. And yeah, try the talk on electronic and computer engineering if you're interested in this general area of engineering. Okay, thank you. Goodbye.